Today we're going to talk about logarithms and logarithmic functions. Alright, so we know that 2 squared equals 4. But if I asked you 2 to the x equals 6, you probably couldn't come up with that number off the top of your head, because 6 is not a perfect square of 2. So, the way that we solve this for x is by changing it to logarithmic form. Now, to switch from exponential form to logarithmic form, we have to know the different parts of each form. So in an exponential form, we have our base, b, raised to our exponent, which is x, equals our y. Now when we switch this to logarithmic form, we're solving for x, right? So we write x equals log base 2, that's what you would call this little superscript or subscript in the bottom. It would be log base 2, and then of our y, which in this case was 6. Easy enough. We're going to do some practice problems. So, in this case, our 3 is our base, 81 is our y, and 4 is our x. So in order to switch from logarithmic form to exponential form, we put our base to the power of our x equals our y. 3 to the 4th equals 81. Same thing can be done down here. This 7 is our base, log base 7. This 7 is our y, and our 1 is our exponent. So we put our base 7 to our exponent 1 equals our y. 7 to the 1st equals 7. We can do the same thing here. Our base is 14, so 14 to our exponent of 0 equals 1. 14 to the 0th power equals 1. And over here, we can write our base, which is 1/2, to the -5th, our exponent, equals 32. Now we can do the same thing to switch from exponential form into logarithmic form. So, we take, remember this number is our base, our b, this is our exponent x, and this is our y. So remember to switch to log form, we can write log base 9 of log base of our base of our y value 81 equals our x value 2. Same thing down here, our base is 20, so log base 20 of our y value 0.05 equals -1, our exponent, our x value. Alright, our base is 16, so log base 16 of our y, which is 8, equals 3/4, our x value. And once again, right here, our base is 15, so log base 15 of our y, which is 1 over 225, equals -2, our x value. Now, we can solve simple logarithms without using a calculator. If we take our problems that are written in logarithmic form and switch them to exponential form, we can solve them pretty quickly. So, the log base 7 of 49, we're going to say it equals x. So our base is 7, our exponent is x, and that equals 49. Now we know we can write 7x equals 49 is simply 7 squared, so then we know that x equals 2. In this case, our base is 2, our exponent is x, that equals 64. 2 to the x equals 64 is 2 to the 6th, so we know x equals 6. Over here, our base is 16, our exponent is x to the 1/4. We can rewrite both of these in terms of 4. So 16 is just 4 squared, right? So we have 4 squared to the x, which is just 4 to the 2x, equals, and then 1/4 is simply 4 to the -1. So we know that 2x has to equal -1, which means x equals -1/2. Moving on this last problem, our base is 8, so 8 to the x equals 512 when we rewrite it in exponential form. 8 to the x equals 512 is 8 cubed, so we just know that x equals 3. Now we're going to talk about the difference between common logs and natural logs. So common logarithms are logs with a base of 10. Log base 10 is just written as log. Because if there's no base, we can assume it's 10 because the logarithm scale is on a base 10. The natural logarithm is just a log with a base of e. Previously, we talked about how e was our natural base. So a natural logarithm is log base e. And we just write this as ln. That means natural log. So these simple problems we can do in our calculator. So we can do the natural log, which that button is bottom leftish next to our 4, the natural log of 6, and we get 1.79. We can do the natural log of 5.38. Yeah, just checking. The natural log of 5.38 on our calculators. And that gives us 1.68. Let me just round these to the 100th place. 5 times the log of 6.213. Do 5 log 6.213. Notice that this is log base 10 because it doesn't have our base written. And that's the only one that you can use doing the log button on your calculator right there. And so we get that that equals 3.97. All right, and then we can do our natural log of 1/5. Make sure that your entire 1/5 is in your parentheses. And so we get negative 1.61. Why logarithms are relevant, things like the pH scale, the Richter scale for measuring the intensity of earthquakes, and also the way that we measure sound in decibels are all on a logarithmic scale. So that means if our pH of something was 6.5, and the pH of something else, let's say pH of milk is 6.5 and the pH of soda is 2.5. The difference between those is 4. So you might say that soda is 4 times more acidic than milk, but that's not true because pH is on a logarithmic scale. Soda is 10 to the 4th times more acidic than the milk. The same is true with earthquakes on the Richter scale. So if it's a 6 instead of a 4, that's not 2 times stronger. That's 10 to the second, so 10 squared, which is 100 times stronger of an earthquake. And the same also goes with decibels of sound and how we measure it.